Welcome back, children. Last class we learnt about different types of velocity time graphs. We saw how acceleration can be calculated using the slope and how distance was calculated using the area. So today we will learn more about these velocity time graphs, and we are going to derive three equations of motion using velocity time graph. So you can see here all the three equations. The first equation, V equal to U plus AT. This equation shows the relationship between velocity and time. The second equation, S equal to UT plus half AT square, gives the relation between distance and time or position and time. And the third equation, V square equal to U square plus 2AS, gives the relation between position and velocity or distance and velocity. Here A stands for acceleration, U initial velocity, V final velocity, T time, and S for distance. The last equation can also be written as V square minus U square is equal to 2AS. Okay, you can just bring U square on the left hand side, and it can also be represented as V square minus U square is equal to 2AS. Here you can see the velocity time graph of two objects A and B. So what can you infer about their velocities, especially about their initial velocities? For object A, if you see, the initial velocity is 0, whereas for object B, if you see, the initial velocity is not 0, it already has a value, let's say U. So here again you can see that this object has an initial velocity U. So from this velocity time graph, we are going to derive the three equations of motion. So in this graph, you can see that the line dB shows increase in the velocity of the object from U to V. As I already told you, for calculating the equations of motion, or for deriving the equations of motion, we will be calculating both acceleration as well as distance. So we will be completing the figure by just joining these lines. So the line was initially dB. So we are drawing a perpendicular line from the point B to the time axis and a parallel line to the time axis by joining it to the velocity line. Similarly, we are joining from the point D, we are joining it to the point A. So this will complete the figure and will enable us to derive the equation. So if you see here, O to D will be the initial velocity U, and from O to C is the final velocity V. If you see, OD and AT, they are of the same length. So this is also U, and BT is also equal to OC, which is V. So remember this, because using these measures we will be calculating the acceleration and getting the first equation of motion. So observe this figure carefully. This is a velocity time graph of an object which has an initial velocity u and a final velocity v. OA represents initial velocity and OE represents final velocity, and T represents time duration between 0 and C. So the figure is completed here. Now here in this figure, if you see BC, the length BC is equal to BD plus DC. And we know that BC is nothing but the final velocity V, because BC and OE are of the same length. So BC equal to V, which is the final velocity. If you consider DC, DC is of the same length as OA, which is nothing but the initial velocity U. Now if you take BC, BC, as I told you, is BD plus DC, or we can write it as BD plus U. So we know that BC is equal to V and DC is equal to U. So the value BD is V minus U. Now as I told you earlier, here for deriving at the first equation of motion, we are going to calculate the acceleration, and acceleration is equal to the slope of the velocity time graph. So acceleration, which is represented by A, is equal to slope of the line AB, which is BD by AD. And we already calculated BD is equal to V minus U. And AD is nothing but OC, which is T. So by applying it, we get A is equal to V minus U by T. Or by cross multiplying, by taking T to the other side numerator, we get AT is equal to V minus U, which is nothing but V is equal to U plus AT. And this is the first equation of motion.